Alright, the next set of notes is RAT3. Now RAT3 is about adding and subtracting rational expressions. Adding and subtracting rational expressions. Now, if you remember, rational expressions, because it has the word ratio in it, it implies that we're dealing with fractions. And because we have expressions, we're dealing with variables as well. Now, because we are adding and subtracting fractions, things are going to get very complicated. Adding and subtracting fractions is significantly harder than multiplying and dividing fractions, unfortunately. Why is that? Well, the key concept here. Key concept here is to add or subtract rational expressions you must first determine the least common multiple. The least common multiple, also called the LCM. You must determine the least common multiple, otherwise known as the LCM, of the denominators. Now, the LCM of the denominators is a very important concept for anything fractions because it has another name. This is also called, or this is also known as, the least common denominator. So if you remember from a Quinton or Hamilton Holmes, you got to find the common denominator when you add fractions. That's what we're doing here. That is what we're doing here. We are finding a common denominator. Alright, I'm going to adjust my camera here by putting it on a little bit of a stool. That way it shows more of this sheet at once. Okay, now for the example problems. This can be done with numbers, as we know. We can do this with numerical fractions. Okay. This is 5/6 plus 4/9 as our first example. 5/6 plus 4/9. That's an ugly looking 6. I'm going to try that again. 5/6 plus 4/9. This is a 9. Once again, if you are watching this without sound, you might as well not be watching. If you are watching this without sound, you might as well not be watching. Please watch this with sound. Okay. So, we cannot add straight through. That's not a thing with addition. Instead, we have to find the least common multiple of the denominators. So let's break them down. 6 is equal to 2 times 3. 9 is equal to 3 times 3. So in order to find the least common multiple, what we are going to do, well, okay. First of all, if you can do it by inspection, if you can look at it and say the least common multiple is 18, good job. Do that. If you can't, this is how you can figure it out. So, here we have 2 times 3 and 3 times 3, right? 2 times 3 and 3 times 3. So, we have these 3's in common. Because we have a 3 in common, we only need to list that 3 once. So we list everything else. We have this 2 from the 6, and we have this 3 from the 9. And then we have another 3 in common with both. So the least common multiple is 2 times 3, which is 6, times 3, which is 18. So this is going to be our least common denominator, which means we can rewrite both of these fractions as something over 18. And this is the smallest denominator that works for both fractions. Now, when we do the numerator, we can't just write 5 and 4, because then they would be different fractions. Instead, we have to adjust the numerator so that it's still the same fraction. Now, to go from 6 to 18, you have to multiply by the 3, which is missing, right? The LCM is 2 times 3 times 3, but only the 2 and the 3 here make up the 6. So this remaining 3 is what we multiply both the top and bottom by. So what's missing is that last 3, so we have to multiply the top by 3. And 15/18 is now an unreduced form of 5/6. So we know that we've done it right, because if we were to re-reduce this fraction, we would get 5/6. We've rewritten 5/6 as something over 18. Now, for 4/9, we have 3 times 3 in the denominator already, and we have to add on another 2, or we have to multiply it by another 2 to get 18. So we have to multiply the numerator by 2 as well. And then we get 8/18, which is equal to 4/9, just rewritten as something over 18. And now that both denominators are the same, now we can add them together. So we have 15/18 and 8/18. That gives me 23/18. And that is the answer. Alright, next one is 6/14 minus 10/35. 14 is equal to 7 times 2. 35 is equal to 7 times 5. The LCM, therefore, we have a 2 and a 5, but we have the 7 in common, which means that we have a 7 listed once. We don't put 7 times 7, we just put 7 once because it's a common factor. So we have 2 times 5, which is 10, times 7, which is 70. So our least common denominator is 70. Okay. Now, 6/14. 14 is 7 times 2. What's missing is the 5. So the least common multiple is 7 times 2 times 5. The 7 and the 2 come from the 14. And the 5 comes from the 35 and is missing. So we have to multiply both the top and bottom by 5, and we do indeed get 70 on the bottom, and then on the top we get 30. 14 times 5 is 70, 6 times 5 is 30. Now 35 is 7 times 5. What's missing is the 2 in the least common multiple, so we multiply 35 times 2 to get 70, and 10 times 2 to get 20. And we get 30 minus 20, which is 10 over 70, which reduces to 1/7. Okay. So that's the general idea. Now we have to deal with polynomials. Okay. So our first sample problem is x plus 2 over x plus 6 plus x plus 3 over x plus 5. Okay. You'll notice that all of these denominators are different. Or all of these parts, I should say, not just the denominators. All of the numerators and the denominators are different. Let's find the LCM of the denominators. So first of all, we have x plus 6. That doesn't really factor. And then we have x plus 5, right? That also doesn't factor. But the LCM is this times this. Alright? Meaning our common denominator is going to be x plus 6 over x plus 5. Okay. So now we have to figure out what's missing. In the first fraction, we have the x plus 6. What's missing is the x plus 5 in the least common multiple. So we have to multiply x plus 6 by x plus 5 to get our denominator, and multiply x plus 2 by x plus 5 to get what's on top. Now for the second one, we have x plus 5 here. What we're missing is x plus 6, so we multiply x plus 5 by x plus 6 to get the common denominator, and x plus 3 by x plus 6 to get what's on top. And again, we have to multiply this by x plus 6 because when we multiply fractions in general, we have to, or when we unreduce fractions in general, we have to multiply both the top and bottom by the same thing. Otherwise, we're changing the fraction. So now we have a common denominator. Do not reduce. Do not reduce, otherwise you'll be in a loop. So we have x plus 2, x plus 5, plus x plus 3, x plus 6, over x plus 6, x plus 5. And for today, we're going to leave it like this, just for today. Yes, we can simplify this more, but for today we're going to leave it like this just to get the general gist across. Okay. The next, I'm going to do two more. There is a fourth sample, but I'm running out of space. All right. If you're making up these notes at home with a blank sheet of paper, just do the 3 that I'm doing. If you're making up these notes with 4 samples, like with the actual sheet, then I want you to try the fourth sample on your own. Alright, 12y over 5x plus 5x over 4y cubed. Now some of you might instinctively try to cancel the 5x's. Don't do that. This isn't multiplication. You can't do that because this is an addition sign here. Okay, 12y is equal to 12 times y. Whoa, 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 whoa. Don't do that. Some of you might be inclined to do that. Why not? That's 12y. It's not in the denominator. 5x is equal to 5 times x. 4y cubed is equal to 4 times y times y times y. So the LCM is going to be equal to 5 times 4 times x times y times y times y. Okay? In other words, 20xy cubed. Okay? The reason why we have to write all of it out is because there's nothing in common here. So, our common denominator is 20xy cubed. Okay, next order of business. 5x here has the 5 and the x from the LCM. The rest, the 4 and the 3 y's, we have to multiply both the top and bottom. So we have 12y times 4y cubed over 5x times 4y cubed, which is the 20xy cubed. For now, I'm going to leave it like this. Next class, we're going to actually do the rest of this out. But for now, I just want us to get used to the idea of common denominator. Alright, next we have 5x on top. 4y cubed is the denominator. That takes up the 4 and the 3 y's from the LCM. What's missing is the 5x, so we multiply both the top and bottom by the 5x. So 5x times 5x. And then the bottom is 4y cubed times 5x. So now we get 12y times 4y cubed plus 5x times 5x. All of it over 20xy cubed. And for now, we are going to leave it like this, just for today. Next class, we are going to do the rest of these out. But for now, we're going to leave it like this. Alright, the last sample that I have is 3 over x squared minus 3x plus 2, a factorable trinomial, plus 5 over 2x squared minus 2. What I want everyone to do is pause and try to factor both of these denominators. Alright, so we have x squared minus 3x plus 2, which should be equal to x minus 3 and x plus 3 and x minus 1, I believe. Yes. No. This is, it multiplies to positive 2. Hang on. I'm trying to do too much at once. It's x minus 2 and x minus 1. Okay, x minus 2 and x minus 1. Those should be the two factors. Yep. Because it multiplies to 2, adds to negative 3. Okay. 2x squared minus 2 has a GCF of 2, which leaves x squared minus 1, which is a difference of squares. Therefore, we get 2x minus 1, x plus 1. The LCM, therefore, we have x 2. I should list that first. We have the 2 here, the x minus 2. Those are not in common, and the x plus 1. And then we have a common x minus 1, so we only need to list that once. And so our common denominator is 2 times x minus 2 times x plus 1 times x minus 1, and we're going to leave it like that just for today. Okay, so our first fraction was 3 over x squared minus 3x plus 2. This fraction here takes up the x minus 2 and the x minus 1 from the least common multiple. What we're missing is the 2 and the x plus 1, so that's what we need to multiply both the top and bottom by. So we're going to get 3 times 2 times x plus 1. There we go. And yeah, we can absolutely multiply 3 and 2 together to give us 6. That's not a problem. I know we can do that. We don't need to spend another day on that. And then we have a 5 over here, and the denominator here takes up the 2 and the x minus 1. So what we're left with is the x minus 2 and the x plus 1. So that means we have 5x minus 2 x plus 1 on the top. When we write the rest out, hang on, that's not correct. Should just be 5 and x minus 2, because this denominator here takes up the 2, the x minus 1, and the x plus 1. There we go, the 2, the x minus 1, and the x plus 1 from the denominator, and all we're left with is the x minus 2. So because this denominator here, 2x squared minus 2, factored into these 3 parts here, the only part that isn't in this denominator, that's in the LCM, is the x minus 2. So that's the only thing that we have to multiply the numerator by. So we're left with 6 times x plus 1 plus 5 times x minus 2 over 2 times x minus 2 times x plus 1 times x minus 1. And I'm going to leave it there. Again, the point of this lesson is just for us to get used to the idea of common denominator. We'll get to the nitty-gritty when we actually simplify all this out, but I'm going to save that for next class. Alright, that is where I'm going to leave it. There is another sample problem on there. If you have the full notes, I want you to do it on your own, and then do the sample problems on the back. Goodbye.